Okay, taking you back to algebra time, when you have fractions, there's three possible places you could put a 0. I'm going to use numbers here. 0 over 5 equals x. Actually, let's go. I'll go with it. Okay, what's x here? 0. Cool. Okay. What's x here? Okay. Why is it undefined? You're told that it's undefined. Why? All right. One way is to think about a division. How do you divide 5 into no parts? That's ridiculous. Another is an algebraic way. Isn't this equivalent to 5 equals some number times 0? Well, what number times 0 is 5? There is no number defined to make that happen. There is no defined number. So that's undefined. Let's talk about 0 over 0 then. In an algebraic way, this would be 0 equals x times 0. Could x be 1? Yeah. Could x be 2? Could it be 5? Is there any way to find what x truly is? So there is an x, we just can't determine what it is, right? That's why it's indeterminate. We have no way of knowing what it is, okay? We have no way. This then is one indeterminate form. Infinity over infinity is also an indeterminate form. That's the idea of the day. When you get a limit where both are getting small to 0 or both are getting to infinity, what does it equal? I can tell you it is not necessarily 0. It's indeterminate. Now, whether you know it or not, you've been using L'Hopital quite a bit. Anytime you use end behavior. If I say, what's the limit as x goes to infinity of e to the x over x, it is 4. Infinity. I don't know what it is. Why do you say that? You're right. It's because e to the x bigger. What do you mean is bigger? It goes to, okay, that's what I was looking for. Goes to infinity, grows faster. It gets bigger faster. They're both getting bigger. If you look at a comparison of these two in a table, at 1, okay, e is 2 and x is 1. At 10, e is big and 10 is big. They're both going to infinity. X goes to infinity and e goes to infinity. The question is, which goes to infinity faster? And surely the e is kicking the bejeebies out of the x. By the time you get to e to the 1000th power, you're talking 1.7 times 10 to the 434th power. Did Miss Cannon give you that description of like how powerful e to the x is? Do you have any idea?
Crazy.
Gosh, if you drew this to scale and this was 1 centimeter, at e to the first it would be about 2.7, and by e to the second it would be 9ish or so, like this. But if you just to scale when e to the maybe 5th power, it would already be as tall as the cash register building. Okay, downtown. It exponential grows stinking fast, really fast, all right? Now, when we direct sub, we get infinity over infinity, but we know that it's infinity because e grows faster. It's not 1, it's not infinity over infinity is 1, because infinity isn't a number like 5 over 5. It's an idea. And you do not say infinity over infinity is 1 any more than you say love over democracy is 1. They're ideas. They're not numbers to be canceled. Understood? Now, when I say that this goes to infinity because when I say because e grows faster, that's the same as saying e has a greater rate of change, which is to say that e has a greater derivative. L'Hopital then compares derivatives. To know which grows faster, you need to know which one grows with a bigger derivative. L'Hopital's rule then says, rather than take the limit on the function you see, take the limit of their derivatives. What happens to their growth rates as time goes on? Which has a greater growth rate? So then, if you then want to do a limit that comes out either 0 over 0 or infinity over infinity, then you can compare their growth rates, which is to say take the limit of their derivatives and see how their derivatives compare. That's L'Hopital's rule. To evaluate an indeterminate limit that comes out to 0 over 0 or infinity over infinity, take the limit of their growth rate comparison, or their growth rate ratio, or the ratio of their derivatives, right? Now then, this is what the work should actually, so let's go to deciding, are these an indeterminate form in L'Hopital or a non-indeterminate form? That's the first part of the L'Hopital problem, is you have to say, is this a L'Hopital problem? Just like in USUB, you have to know when to use it, when not to. This, as x goes to 0, does the top go to 0? And does the denominator go to 0? That is 0 over 0, so that is a L'Hopital. Yes, this would be a L'Hopital case. Now, when we actually do the problem, we would then use derivatives and do L'Hopital's rule, but we're not there yet. What about the next one? Cosine of x. As x goes to infinity, what does cosine go to? It goes to, well, it never really converges, but always stays between what and what? Negative 1 and 1, yeah? It oscillates between negative 1 and 1. What about the bottom? What does it go to? Infinity, okay. So the top not converging to a number kind of bothers me, but it's not too bad, because no matter what it is, it's pretty small, divided by infinity. Is this indeterminate form, or is it, I know what the answer is? What's the answer? 0. Okay. You wouldn't use L'Hopital then, because it's not called for. You know what the limit is. You wouldn't compare the ratios. It's not a 0 over 0 problem. All right? This guy, let's do another couple. How about the top? As x goes to 4, x cubed minus 64 goes to 0. X squared plus 16 goes to 32, and therefore the answer is 0. Not indeterminate. No L'Hopital. You know the answer, call it good. Okay? How about the second one? Cosine of 2x minus 1. The top goes to, what's cosine of 0? 1. 1 minus 1 is 0. What about the bottom? Sine of 5x? 0. So this is a L'Hopital case. We would use L'Hopital here, which, again, we'll do in a second. All right? If it comes out to be 0 over 0, it's indeterminate form, we'll use L'Hopital. What about the next one? The numerator goes to? Oh, we already did that. What the heck? I don't know what I'm thinking. Sorry, my bad. What about the fourth? Tangent of pi over the tangent of x goes to, it might help to think of the graph. Isn't this what the tangent graph looks like? As you approach pi over 2 from the left, you're this way. What does y approach? It goes to infinity. What does x approach? Pi over 2. Is that indeterminate form, or is that I know what it's going to be? What it's going to be. Okay. What about cotangent? I don't know if you remember your cotangent graph, but it looks like this. Because it's cosine over sine, it has an asymptote at 0, because sine equals 0 is in the denominator. So it has an asymptote there. As x goes to 0 from the positive side, cotangent goes to infinity. What about x to the negative 1, or 1 over x? As x goes to 0, 1 over x goes to infinity. Is that an indeterminate form? Yeah, there are two, 0 over 0 and infinity over infinity are indeterminate. We would use L'Hopital. Okay, that was practice on when to use it. Now let's talk about how to use it. What the work should look like. I'm going to be a little picky about the work, because AP in the last 2 years got really picky about the work, and so it needs to be said just right. I will, just a warning right now, If you fail to show appropriate work on the homework, I will count off as skipping it, all right? So that's one. Not wrong, which I don't normally have a problem with. I'm saying you skipped it. You didn't do it at all right? So make sure you show the work appropriately. Use your notes as a reference if you're not clear on what I want. This is what I want. First of all, if you suspect L'Hopital, and I do here, this is 0 over 0, yeah? Then you need to show limits individually. They changed a bit ago to say if you do this, you're out. AP stops reading it. They have a problem with the way that is written or writing it 0 over 0. I'm not on the committee, so I'm just going to do what they said to do, and this is what they want. They want you to show each term individually goes to 0. Wouldn't you agree that sine does go to 0 as x goes to 0? Wouldn't you also agree that x goes to 0 as x goes to 0? The minute you've then shown that the top and bottom go to 0, fight the temptation, right, 0 over 0, then you'd say something like, by L'Hopital, the limit is equivalent to cosine of x over 1. Now, what I'm saying then, the L'Hopital's rule, what I'm talking about is, if you decide, yes, it's in the determinate form, then we want to compare their growth rates to each other. And when you apply L'Hopital's rule, you're going to take the derivative of the top and the derivative of the bottom so you can compare their growth rates. So that's where cosine and 1 came from. They're the derivatives. You follow? Notice I did not say take the derivative of this whole thing. You take the derivative of each piece because you are comparing their separate rates. It's always a case that people think, oh, I use the quotient rule. I don't want to know what this whole thing's rate is. I want to know what this rate is versus that rate. It's each individual derivative. Do not use the quotient rule. Understood? Okay. The idea is now you'll get a limit that's doable. As x goes to 0, cosine goes to 1. Now that is to say then that the limit of this is 1 probably because they approach 0 at exactly the same rate, and so they were looking more and more like each other as time went on. The limit is 1. That's what L'Hopital's rule looks like. You first justify with showing each individual limit is an indeterminate form. You take derivatives, and then you take the limit of the new derivative limit. All right? So let's go to this guy. It feels like maybe infinity over infinity. Let's go here. The limit as x goes to infinity of the top. Here's the graph. As x goes to infinity, what does y go to? X is definitely getting bigger. Y is getting smaller? Isn't y getting bigger? Okay, so the limit is infinity. Log of big is big. What about the square root in the denominator? It also will get bigger. The bigger the number you square root, the bigger the result is. And so this is an indeterminate form. Because it's in the determinate form, we'll use L'Hopital. That means we take the limit as x goes to infinity in this case. That stays the same. This time x is going to infinity of the derivative. What's the derivative of the top? 1 over x. What's the derivative of the bottom? 1 over 2 root x. Now that on the surface is kind of still indeterminate. So would you take a clean-up step so we can evaluate the limit a little better? If I clean this up, this is the same as 1 over x times 2 root x over 1, which is the limit as x goes to infinity of 2 over root x. If I simplify root x over x, isn't it root x in the denominator? Cool? Are you with me? Okay. As x gets large, where does that approach? 2 divided by a huge positive is Now, if I were to interpret that, that means the bottom must have grown much faster than the top, and it caused it to go to 0. All right? Do you feel like you understand enough to try this yourself, or try one more? Do one more. Okay, so this guy. The limit as x goes to 0 of e to the x minus 1. What does it approach? 0. The limit as x goes to 0 of sine of x. What does it approach? I'm getting 0 over 0. Is that an indeterminate form? When I have an indeterminate form, I use L'Hopital's rule. So by L'Hopital, the limit as x goes to 0 of what? E to the x is the derivative of the numerator over cosine of x is the derivative of the denominator. Now evaluate the limits. As x goes to 0, e to the x goes to 1, e to the 0 or 1. Denominator, cosine of x goes to 1, and so the limit is 1. All right. Try one on your own. I don't know if you did secant or replaced it with 1 over cosine. But it is a L'Hopital case. The derivative on the top is secant squared. The derivative in the denominator is 1. That's 1 over cosine squared, which is 1. How'd you do? Okay, try now. That's usually helping you. It won't change. It usually just eliminates a d and e. The next one is x approaches 0 from the right. What does log or the y values approach on the graph? Negative infinity.
Good morning, Devlin Jaguars. Please rise to the Pledge of Allegiance. I begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Think this way. That's not indeterminate.
This is wish week for Alice, the 30-year-old girl. She would like to go to Disney World. If you are able, please bring a donation to the $10
Instead, think this way.
Let's help send little Alice to Disney World.
The top is a large negative. The bottom is a small positive. Will it be negative or positive?
We want to see your amazing work. Submissions are open.
Negative. And if you take a large number divided by a small
For
number, what do
students
you
who
get?
participated in the 2018
A really big
GE
number.
Girls Summer Camp, and for others that are
It's not
interested in
indeterminate.
STEM, GE invites you to join their first Camp to College informational and goal-setting meeting, Friday, February 8th during 7th hour in Miss Newcomb room. You'll get the opportunity to interact with engineers and students from Colorado School of Science. You will also get to experience fun science and engineering activities at 7th hour throughout the semester. Don't miss out. This is open for girls that are in grades 7 through 12 and will be first come, first served. There will be paper sign-ups in Miss Newcomb's room, West 106. Sign up by February 7th.
Have you ever wondered how the yearbook gets made? It isn't.
The last one requires great skill derivative-wise.
For only
It is indeterminate form.
the yearbook to decide which one of your friends you can put in a book for the whole school to see. If it catches your interest, please set up with your English teacher on Wednesday, February 6th, and come to the yearbook interest
that gets tickets. If you want to go to a game, stop in the office and pick one up.
Senior high students. Students interested in AP Computer Science, there will be an informational meeting in computer labs, ME 202 during 7th hour today. There's no need to sign up for 7th hour. There will be a paper sign up after the meeting.
The AP Chemistry pre-test for freshmen interested in taking AP Chem next year will be on Wednesday during 7th hour. Sign up for 7th hour on Wednesday with Ms. B and to take the test.
Okay. I'll continue. You should be able to do most of the homework.
There will be an informational
Let me know what questions you have on last night so I can put them up in lunch.
High school spring athletes. The athletic online registration window is now open. Please register for your spring sports by February 20th. Thank you for your assistance.
13,
Girls tennis players. There will be an interest in
5, did you say?
7th hour in the auditorium.
14,
Please come to the
22,
There will be a boys swim meeting today during 7th hour in the cafeteria.
Today is your last day to submit photos and exchange proposals for the DHS team for the chance to win free tickets. Voting will begin tonight.
DHS Kids Baby Hockey Winners is this Saturday from 7 to 10 p.m. Are you going as a character from the movie or as a dance? Either way, get your baby tickets for 12/50 by the church. Involved in the dance. See you Saturday.
Junior high students, we're sincerely musicians. The Denver Junior High Boosters are hosting a winter social to celebrate. This fun event will take place tomorrow from 2:30 to 4 p.m. in the cafeteria. Tickets are $5 and must be purchased during lunch today and tomorrow outside the cafeteria. That's all your announcements. Have a great day.
The word over a word is just one.
all the letters. Have a good day. Sure. Yeah, yeah. No, if you make eating, in fact, eating the 2x is usually one of the worst use you can make, because the whole idea is that this is represents the original problem. This should be an easier integral, but if you make u e to the 2x, then d is still going to be e to the 2x. So no, you should use this. Look in your notes, but this, the best u is log. Then inverse trig, then algebra, polynomial algebra. So in this case, the next best u is an algebra term of x, and the worst u is more trig. Okay.
Thank you.
You're welcome. Hi, B. Hi, B. Just with all the
I love just having an entire section just myself. I could just
spread
spread out
out,
all my
put
stuff.
your junk all over. You gotta love it. All right, stop this recording. Tori, do you need a pass?
Oh, no, I'm going online.
Okay.